Hello, this is John from caveofprogramming.com. In this tutorial, we're going to look at overloading the assignment equals operator. So we're going to start looking more systematically at operator overloading. Now this seems complicated to start with, and I'm going to give you a lot of details in this tutorial. But you always have to bear in mind that at the end of the day, all you really have to do is try to remember the syntax for doing this, and when you remember that, it's much easier to get a handle on the details of exactly what's going on than if you agonize over the details to start with. So this all comes down to typing and remembering what you have to type, which is not so hard if you look at it that way. So I've got a class called test here. I've given it an ID and a name. I've given it a default no argument constructor. I've given it a constructor that takes an ID and a name, and I've given it a print method so that we can see what's in it. So this enables us to do stuff like this. We can say test1. Let's pass in 10 and Mike, and let's call test1.print. So this should show us what we passed to the constructor and what's now in this test1 object. It's a little bit slow, but there we go. We've got 10 and Mike. Now we can do stuff like test2, and let's pass in 20 and Bob. And now let's say test2 equals test1. I'm constructing this very carefully for reasons that you'll see shortly. Now let's display test2, so test2.print, and let's see what's in it. So if I run this now, we've got, in the moment, we've got the same as test1. So this has worked. It's assigned the values of test1 to test2. The reason for that is that C++ provides, without getting into the details yet, it provides a default implementation of something that causes this to work. And what it's actually doing is a shallow copy. It's copying all the values of the variables in test1 here over to test2. Now sometimes that's what you want. You want a shallow copy, but other times you need a deep copy. In other words, you need to copy in a way that makes sense for what you've got here. For example, if you had an ID that had to be unique for every object, you might want to not give test2 the same ID as test1. You might want to change the ID to a unique ID, but give it the same name. You might also have pointers in here, and the constructor, for example, could allocate memory. If you have a pointer in test1 that's pointing at some allocated memory, and you do a shallow copy the value to test2, you've now got a copy of that pointer that's pointing at the memory test1 allocated. You've stolen test1's memory rather than allocating your own in the copy. So clearly sometimes you want to override this kind of behavior. Let's have a look at how we can do that. So we can think of this as a method call. We can think of it as calling a method on test2 and providing it with the argument test1. Now if you look at this equals operator here, we call it an operator because it performs an operation. It's got two arguments to it. It's got test1 and test2. If we implement a method and call it on test2 and pass it test1, that's also actually got two arguments, because not only is test1 an argument, but methods receive an implicit first argument, which is a reference to the object that they're being called on, and that enables you to use the via some magic, it enables you to use the this operator in your methods. So method calls like print seems to have no arguments, but there is actually an implicit first argument there. So if we implement the equals operator as a method call with one argument, it's actually got two arguments, which you can think of as being this test2 and test1. It needs those two things to do its job. And because it has two arguments to it, basically, we call it a binary operator. So let's have a look at how we could implement the assignment operator here. Well, the first thing we need to think about is the return type, and it's here, looking at this, it's tempting to think that the return type should be void. Surely it's going to be a void method call, which simply takes one argument, plus it's got that implicit first argument. But in fact, we can do stuff like the following. We can say test 3, test 3, and we can say test 3 equals test 2 equals test 1. This is like method chaining. We can chain methods together, providing we return an appropriate object from the method. So from this, if we think of equals as a method call, we're going to have to return from it a reference to this test 2 in this case. So we can think of this as calling a method on test 2 and passing it test 1 as an argument and returning a reference to test 2, which then allows us to do this. It lets us set test 3 to the reference return from test 2, and for that reason the return value of the equals operator has to be a reference to the object that it's being called on. And I'll show you something interesting here, which is that we can actually do this. We can say test 3 dot operator equals test 2. That actually works. And if we do cout here, let's do test 3, and let's comment this out just to prove it's not this that's doing something. And if we run this and we call oh yes, well I've got to actually define test 3, of course. So let's comment this out, and let's do, so we can't do cout. I'll show you how to implement that shortly, but actually now we've got to do test3.print. Okay, I think we've got it working now. So let's run this and see what happens. So in fact, this has worked. So this is equivalent to doing test 3 equals test 2. So you can see that the equals operator really is like a method call where the name is operator equals, and as we've seen here, we've got to return a reference from it as well. Let's go ahead and implement that. So the return type is going to be a const reference, because when we do this, it would be very strange if test 3, setting test 3 equals to this. It would be very strange if that changed test 2. So we want it to return a const reference. So we're going to say const test reference, and we're going to say operator equals for the name of the method here. So it's not just equals. For operators, we have the operator keyword in there as well, like we do here. Now the arguments, well, we've got that implicit first argument of the object that it's being called on, just because we always do with method calls. But the explicit argument is going to be const test reference. Let's call it other. It's const because, again, it would be very strange if equals changed the value on the right hand side, the value that you're passing in when you do this. We don't want that to be changed, so we make it const, and we make it a reference because it's much more efficient to pass references than it is to pass in a whole object, which would also involve having to copy it. Now, what are we going to return here? We're going to return the actual object that we're in. So we're going to just dereference this, and because the return type is a reference, this is an object now. That the dereference this is an object. This is a pointer, remember. So we're just going to return a reference to the object that we're in here. Now, to actually implement the operator, we can just put ID, which is the same as writing this arrow ID equals other.id, and name equals other.name, like that. And we can also, let's put a cout in here, and let's say assignment running. just so that we can see it actually working. So if we run this now, we see that when we do this, the assignment operator is actually running. So the first thing we're doing is printing out this mic here. So that's that. In fact, it might be a good idea to put some couts in here. Let's put cout print test1. Make this a bit clearer, and maybe we could just put a flush there and space there. Let's also have a print here, that's print test2, and let's have one here as well, print test3. So that should be a bit clearer. Let's run this. So when we print test1, we've got, we're outputting here the values that are in the object. That's exactly what we expect. When we print test2, test2 has been set equal to test1, so the assignment operator runs and we print test2. And then finally, when we print test3 here, test3 has been set equal to test2 now, so again we've got the same stuff that was in test1. So that all works as you expect, and the important thing with this is to practice typing it and just think about why the different bits are as they are, but typing is really the key to becoming familiar with this. Now let's take a look at something slightly different here. Let's do a cout endler just to provide a visual break, and let's do test4 equals test1, and then we can test. I've done it again. Let's say test4 equals test1, and let's say test4.print. And let's run this. So that's worked. We've got mic, but there's no assignment operator running, and yet we did use the assignment operator there. What's going on there? Well, this is called copy initialization. Copy initialization. And in fact, what we're invoking here is going to be the implicit copy constructor. So let's actually implement a copy constructor. Let's say here, so the copy constructor is going to be called, it's not going to have a return type because it's a constructor, and we're going to pass in a const test reference other. We've seen copy constructors in my free beginners course, and we want to do this in here as well. And let's output there let's output something so we can see that it's running. So copy constructor running. So now we see that in fact C++ has used the copy constructor to do this. So if you take an object and you don't give it initial values, you just immediately assign the declared object to another. It doesn't actually use the equals operator. It's actually using the copy constructor here. Now there's something called the rule of three in C++, which is that if you define a copy constructor or a equals, that's assignment operator, or a destructor, if you implement any one of those, you should implement the other two as well. So you can see why, if you've got into implementing the equals operator here, then you can see why you'd want to define also a copy constructor, because otherwise this isn't going to be using your assignment operator. But why would you want to define a copy constructor or an assignment operator if you've got a destructor? Well, the answer is that why would the destructor exist? Probably to clean up memory. And if you're cleaning up memory, you've got pointers in your object. And if you've got pointers in your object, you don't want to do a shallow copy, so you want your assignment and equals operators. We could actually do this equals other, and that would also work. So once we've got our assignment operator here, then we can use it in there. I think that's all I want to cover for this tutorial. I'm trying to think if there's anything I've missed here. As far as I can think, there's nothing missing. So the important thing here is to practice this. Try creating your own classes and give them a copy constructor, of course, and define the assignment operator as well. And if I've managed to lose you with all this explanation, when you try these things out for yourself, it will start to become a lot clearer. So you have to bear in mind when you're defining it that you can do this. You have to bear in mind that this will not run the assignment operator. You need a copy constructor. And you have to be careful when you define operators to get references where you need references, and to get const exactly where you need const and not anywhere else. We can't make the whole method const, for example, because then we couldn't actually change the object that we're calling this operator on. So that's it for this tutorial. Until next time, happy coding.